All right, so I thought I would go through completing the square since when I'm tutoring, a lot of the times this is the biggest struggle. And a lot of the times it's just because people don't know the formula behind it. They don't know just the simple steps you should take that you can do every single time to replicate it. And what we mean by completing this square is we're going to take a regular quadratic form and move it into this form here. That is called vertex form, and it's because our h and our k actually represent our vertex. In some cases, depending on the quadratic, it's going to be a minimum, and then in the other cases, it's going to be a maximum. It just depends on what the quadratic looks like. So we're going to work through 4 examples, the first 2 being a little bit easier, and then the next 2 being a little bit harder, and I'll explain why. So starting with this first one, every time I'm trying to complete the square, I remember the first step is the most simple step, but it's going to make sure that you get the whole rest of the thing right. So we're going to start by writing out the first 2 terms. Then we're going to add a blank. We're going to put that all in brackets, then plus our 41 that's out there, and then minus a gap. And so what it goes in that gap? Well, when we rewrite out this form, so we're going to do the exact same thing we just did, put that in brackets. It's going to be half of the middle term, so that's going to be 26 divided by 2 is equal to 13. Square that term, which is equal to 169. So we get 169 plus there, put our bracket here, plus 41, and that minus is actually the same term. So we're going to plus the term and we're going to minus the term outside the brackets. So now what do we do in this step? Well, let's combine those 2 terms outside the bracket. So we're going to keep our bracket there, plus 169, bracket, 41 minus 169 is 128, so we're going to get a negative 128 here. And then the final step is dealing with this. So to convert this form, it's fairly simple actually. All we're going to do is take one of this term, so we're going to take an x, keep the sign that's in front here, then just put whatever the half term is that was here. So 26 divided by 2, which was 13. And then we're going to square that term and then just keep that 128 out there. So when we factor that out, or when we reverse it, we can FOIL this and we'll get the exact same thing as here. So that's our final step, that put it in vertex form that we see above here. Now we're going to move to another example, very similar to the first one. We have no term out in front of here, it's only a 1, and then the rest of the quadratic there. So let's see if we can replicate those steps. So we're going to say, we're going to rewrite out those terms here, x squared minus 8x plus, remember we're going to put a gap, bracket, plus 5 minus by the same amount, whatever that amount is. So in this case, we're going to say, let's write out our term again, and we're going to go minus 8x. 8 divided by 2 is 4, squared is 16, so we're going to add a 16 here. Then plus 5 minus 16, because we're going to subtract by the exact same amount that we added in the bracket. And then so what do we do in this case? Well, we combined our outside terms there, like last time. And then so 5 minus 16, we should get a negative 11. And then our final step was basically, we're going to take 1x, keep the sign of the middle term, and then we're going to take half of that middle term like we did here, but just not square it. So that's going to give us 4. Then square that all. So if we FOILed this out, we will get this, minus 11. And that's our final form. Obviously set it equal to 0 because we're maintaining that this quadratic is congruent to this, aka they're the exact same if you were to FOIL them out. So then this third example is where things get tricky. So the 3 out front, we need to deal with this in a certain way because it's not going to be as simple as just saying we get to our final step here and then we just put a single x and we're good. We're going to see that we're going to have to factor out the 3 at some point, but that may do some complications in regards to the term we put here. So let's start this one off. Let's do the exact same thing we've done before. So write out those terms. We're going to add a term, put it in brackets, minus the 7, minus that same term outside. So now when we do that, we say, I think at this point it would be a good step to pull out the 3 and then see what happens with those other ones. So when we pull out a 3 here, we're left with x squared in the middle, negative 4x in the middle, because 3 out of 12 is 4. And then what happens to the term now? So we say 4 divided by 2 is going to be 2, squared is 4. So we add a 4 here. But then this is where it may get a little bit different from the previous examples, because we're not just going to minus a 4 out here. So like when we did it up here, we had a 16, we minus the 16, no complications. But because we pulled out a 3 here, now we have to do 3 times 4 and put that in the minus here. Because when you pulled out a 3, it still has to scale to whatever we're going to move to the other terms. So this has to multiply by the 3 here. So now, similar to before, we're going to rewrite out our terms. Combine those last two terms, so negative 7 minus 12 is going to be negative 19, I believe, yes. And then all we have to do is just simplify this internal like we did up here. So we're going to say 3, write a single x, keep the sign of the middle term, and then just put half of 4, which was 2, squared minus 19. And that should be our final solution for that one. All right, and then similar to number 3, we have a term that's not 1 in the first here. So a is not equal to 1. That's going to make sure that we have to do things a little bit different. But as you could see from number 3, it didn't change much. So let's rewrite out the terms again. We'll write them out with brackets, so plus 8x, and then minus, or we're going to add our term, blank, minus 9, minus the same term. So in this case, let's factor out our 4 again. So we're going to get 4 out front, x squared plus, what's a 4 out of 8? That's 2. So we get 2x. What's half of 2 squared? That's going to be 1 squared, which is going to be equal to 1. So we're going to plus 1 there. But then remember, when we take that term out, it's going to be 4 times 1, not just pulling out 1, because we have to account for the fact that it has the factor of 4 still attached to it. So 4 times 1 is going to be 4, so we subtract a 4 in this blank here. So now let's combine that term there, like we've done before. So that's going to be equal to negative 13. And then we just have to do our final step, which is basically write our 4, single x, keep the sign of the middle, take half of the middle term, which is 1, square it, and then negative 13. So we're saying that this expression is equivalent to this expression. And so essentially, to summarize everything, when we get them in vertex form, essentially that's going to tell us a few things. So we have our scaling factor, we have our vertex, which is going to be the x term in here, so negative 1. Well, I guess we can write that. So let's just summarize for this one. So we have a scaling factor of 4. I'll just write scaling of 4. We have a vertex at negative 1, because we always do the opposite sign of the inside, with keep the sign of this one, so negative 13. That's our vertex. So, and then another thing is, do we have a maximum or a minimum? AK, does it look like this, or does it look like this? Well, from this example, we say that the A term has a positive, which means that it's going to have an upwards sloping, or it's going to have an upwards opening vertex. So we know that this is a minimum. And then that should wrap up the problem there. We've done all 4 of the problems. As you can see, when there's not a one term here, it changes things a little bit. We have to pull a factor out and then make sure we apply the scale when we pull it out here. But other than that, it's very, very simple. They're all very straightforward.